Welcome, I'm glad you're here. Whether you're listening beneath the hush of midnight or curled beneath a quiet sky, this moment is just for you. Tonight we drift into the story of stars, not just how they shine, but how they go on even after their light fades. We'll explore how endings in space are never truly final, and how every atom around you remembers a star that once burned. If this brings you peace, a gentle like or soft subscribe means the universe to me. And I'd love to know, where in the world are you listening from? What does the sky look like where you are? Let your mind rest now and let the starlight carry us home. Long before the earth turned, before oceans breathed or wind spoke across stone, there was only gas, dust and quiet. But even in that silence, something was gathering. In the deep stillness of space, clouds of hydrogen, the simplest, oldest element, began to drift closer together, pulled by gravity, drawn inward slowly, gently, invisibly. They did not know what they were becoming, only that they were falling, folding, compressing into the possibility of heat. And as the center of those clouds grew denser, temperature rose, pressure mounted, and atoms that had wandered the cosmos for eons began to collide in a new way. At a critical point, a star was born, not with sound but with fusion. A quiet ignition that would burn for millions or billions of years. This was not a spark, not a flame, but a constant transformation, the conversion of hydrogen into helium, light, and life's future. Every star is a furnace, but not like fire on Earth. In stars, atoms do not burn, they fuse. They press so close under gravity's weight that their very cores merge, forming something new and releasing light in the process. This light pushes outward while gravity pulls inward, creating a balance. This balance is delicate but enduring, lasting for most of a star's life, and in that life the star quietly manufactures the elements needed for everything that will follow. Helium from hydrogen, then slowly, carbon, oxygen, silicon, iron, the building blocks of stone, sea and skin. The core of the star becomes a factory for matter, but it does not know where its creation will go. It simply glows, steadily, faithfully. From a distance, the star seems still. Some of the atoms inside that star, the very ones forged from its relentless fusion, will one day become your breath, others your bones, others the calcium that lets your heart beat. This connection is not poetic metaphor. It is literal. The atoms in your body were born in stars, not one, but many. Some long before the star even existed. They travel across space after the star's end, carried by winds of radiation or hurled outward in a supernova's final release. These atoms floated in the dark, unclaimed, until they joined clouds that formed new stars, new systems, new planets. Earth formed from such material. Recycled stardust pressed together under new gravity, and when Earth cooled and water pooled and cells began to divide, the atoms found yet another purpose. They became life. Even now, every part of you holds that legacy. Not in memory, atoms do not remember, but in presence. The iron in your blood comes from ancient stars, the oxygen in your lungs too. Every breath you take is a whisper from a past so distant it cannot be seen, only felt. The universe does not forget. It reuses, it recycles, and it creates with patience. You are not separate from the stars, you are not their descendant, you are their continuation. The fire that made you still burns, not in your cells, but in your chemistry, and that chemistry sings quietly every time you move, every time you think, every time your heart returns to its rhythm. This story, the one you carry, is older than Earth. Older than the sun. It began in a place without direction or name. It travelled not in a straight line, but in waves. Waves of energy, of motion, of time. And yet somehow it arrived here. Into a body that dreams. Into a voice that speaks, into a mind that asks, where did I come from? The answer is in light, in fusion, in time. And it is also in stillness, because even though the universe is in constant motion, the particles that form your body are older than the land you walk on. They have been still, and they have moved. They have seen heat and vacuum, light and shadow, and now they rest as you rest. When you close your eyes, your body does not vanish. It continues its quiet work, circulating blood, exchanging gases, repairing, renewing, remembering. And in that stillness, the star-born atoms hum. They hum with the music of physics, gravity, electromagnetism, weak and strong nuclear force. The four rules that govern everything. These forces shape the stars, and now they shape you. They guide how your neurons fire, how your muscles contract, how you feel warmth or fear or comfort. Science is not separate from your experience. It is the stage upon which your experience dances. This connection, from you to the stars, is not just beauty. It is truth. It is measurable. It is taught in classrooms and confirmed by spectra and equations. But it does not lose its poetry and approval. If anything, the proof makes it more sacred. Knowing that your blood carries the signature of a supernova, that your bones hold the same calcium that once drifted between galaxies, that your body is not on the Earth but of the Earth, and the Earth not apart from space but born in its fires. This is not romanticism. This is astrophysics, and it is deeply, quietly human. The next time you see a star in the sky, maybe through clouds, maybe faint behind city lights, remember that it is not separate from you. The light you see may have taken thousands of years to arrive. It may be from a star that no longer burns, and yet it reaches you. Photons crossing space not to teach but to touch, to land softly on your eye, trigger a signal in your brain and remind you we are part of this. Even as the world below moves fast, the truth above remains steady. Stars are born, they live, they die, and in that cycle you are included. You are not a spectator. You are a participant. And even when the stars fade from sight, their matter continues. Their work continues. And in you it continues too. So rest now, knowing you are made of things that never truly die. The light that started your story still echoes softly in your breath, in your blood, in the fire that made you. In the great darkness between galaxies, silence stretches wider than thought. There are no cities here, no noise, no breath, only drifting clouds of hydrogen and helium, ancient and patient. They move slowly, too slow to measure with hands, too vast to see with eyes. For millions of years they wander, not seeking anything, just existing. These clouds are cold, diffuse and quiet, but in the stillness of space, even quiet things can gather. A passing wave of gravity, a gentle pull from a neighbouring star or a distant supernova can ripple through the gas. It doesn't take much, just a little nudge, a soft compression, and something begins to happen. The cloud starts to fold inward. It shrinks, curls and thickens. A slow collapse begins. Gravity is the architect here. It pulls inward on every atom, every particle of dust, every strand of gas. As the cloud condenses, its centre grows dense and hot. Pressure builds. Atoms fall closer together, speeding up, crashing into one another. The temperature at the core rises to thousands, then millions of degrees. Deep within this collapsing sphere, a seed forms, a protostar. It is not yet a star, not fully. It glows, but not from fusion. Its light is only heat, friction and pressure. Still, something vital has begun. A centre has formed where none existed. A future is waking in the heart of gas. Outside the core, the rest of the cloud continues its slow descent. Some of it forms disks that spin around the growing centre, swirling rings of material that may someday become planets, moons or asteroids. But all of it, for now, is focused on feeding the centre. As more gas falls inward, the protostar grows. The pressure in its core climbs higher, and at a certain threshold, when heat and density reach their breaking point, hydrogen atoms begin to fuse. This moment is delicate, invisible and monumental. Two hydrogen nuclei push together with such force that they merge, forming helium. In the process, a tiny amount of mass converts into energy, a lot of energy. This is nuclear fusion. It is the same process that powers every star in the sky. It begins quietly with no flash, no roar, but once started it does not stop easily. The fusion reactions continue, releasing light, heat, and the pressure needed to push back against gravity. The protostar is no longer just a ball of gas. It is a newborn star. A balance forms, a long truce. Gravity pulls inward, always. But now light pushes outward. The star shines not because it burns like firewood, but because it is turning mass into energy, constantly, reliably, peacefully. This balance, called hydrostatic equilibrium, allows the star to remain stable for millions or billions of years. From the outside it looks calm, but it was born the same way. Inside it is a crucible of constant transformation. The kind of star that forms depends on many things: mass, temperature, the density of the original cloud. Stars are not born in noise. Small, red, they are born in stillness, called red dwarfs. They live the longest, sometimes trillions of years, sipping their hydrogen slowly. Its birth is only the beginning of a long, large and bright blue giant. From the moment fusion begins in its heart, the star enters a quiet between, not of motion, yellow mains, but of becoming. Middle-aged by cosmic standards, it balances force a collapsing cloud about 4.6 billion years ago. In harmony. Its light has bathed Earth, the main sequence. Stars do not form alone. Spend the majority of their life in clusters. Stellar nurseries in this phase, where hundreds or thousands of stars ignite within vast clouds of gas hydrogen atoms in its core. These regions glow in infrared, releasing energy with each reaction. Deep space photographs. This energy pushes shimmer with possibility, countering the inward pull of gravity. Over time, the stars drift apart, scattered by gravitational tides. Stillness push of their own wind billions of years. For a while they are siblings. Inside the star is the same cloud under the same conditions. It is a slow storm of a star is not quick. Photons created in the tens of millions of years, thousands of years to collapse to full ignition. Bouncing, scattering, absorbed and re-emitted beyond the reach of any single life. This chaotic diffusion, it is makes the journey of light from the center of the star to its edge, some quiet corner of a distant nebula. A star is forming. When that light finally escapes, one that will light new travels through space life or shine for a future we cannot see, uninterrupted and unwavering. Every star that energy a star emits slow ecosystems melts ice, begin as nothing more than cool gas, oceans scattered, but the star itself remains far away. Their birth are not loud, burning steadily. They do not shout, they do not demand. Stars vary widely in size, mass, and color by fusing smaller stars like red dwarfs light, burn cool and slow, know what consuming their fuel gradually, and they shine of years longer than the light a star emits travels through space. Larger stars crossing unimaginable distances, phasing through their hydrogen. Some of that light will be absorbed by dust. Some blue giants may live only a few million years. Some will continue for billions of years by cosmic standards, only to land softly on a telescope. Follow the same pattern. A delicate dance. When you look up at a star, expansion, you are seeing its past. As hydrogen in the core is consumed, years ago, helium builds sometimes up. Centuries, sometimes slows, humans pressure drops, and gravity. That tiny glow is not just brightness. The core contracts, it is time, and the star begins to evolve. Stars are not just celestial objects. As the core compresses, temperatures rise again. Their lifespans, positions, and brightness. Helium fuses into carbon into oxygen. Their light carries oxygen into heavier chemical signatures that tell us what elements they're made of, how old they are, how far they've travelled. Each new layer of fusion releases energy. In that glow is supporting the star a little longer. Every shells of different reactions form inside, like the layers of an onion. Outside is another voice in the chorus of the cosmos. Some of those voices will end or supergiant depending on its mass. Others will explode. Its outer layers cool and spread, scattering heavier elements into space. From a distance, the future becomes more luminous, but none of them are wasted. Hotter. Each one plays its part in the great unfolding of swelling is a sign of age. To know how a star is nearing its limits, to glimpse the beginning of everything else, to produce energy, life, but the process is more complex. All of it follows. Without stars, there would be no chemistry, pulses of expansion, no carbon, contraction, no ripple through the outer layers. The stars do not just light the night. The core, meanwhile, shape the very possibility of day. For stars when like you close your eyes tonight, ends in a gentle rest beneath a roof or a sky. The outer layers drift away into space, somewhere, forming a glowing shell called a planetary nebula. It will burn long after we are behind as a white dwarf. It will give light to futures we will never meet that will slowly cool over billions of years. For larger stars, the story ends differently. Their cores become hot and heavy enough to forge iron. The final element it will send may someday become part of another release energy when another story. It consumes it. So when iron builds up in the core, fusion halts, and from that stillness, they become everything. Gravity, no longer balanced by outward pressure, collapses the core in an instant. The result is a supernova, an enormous explosion that can briefly outshine an entire galaxy. In that explosion, elements heavier than iron are created. Gold, uranium, iodine. These are thrown into space, enriching the cosmos with new ingredients. What remains at the center depends on mass. A neutron star, small and incredibly dense, may spin in the dark like a cosmic lighthouse. Or, if the core is heavy enough, it may collapse into a black hole, a point of no return where not even light can escape. But even in these endings, the star's influence does not stop. Its dust becomes part of new clouds, its elements join the makeup of planets, its light continues to travel across space. Its existence shaped the chemistry of everything that follows. The life of a star is long but never wasted. Every phase, from birth to death, plays a role in the larger story of the universe. Without stars, there would be no carbon for cells, no oxygen for breath, no light to guide photosynthesis. The calcium in your bones, the iron in your blood, the gold in a ring, all were forged in stars. Stars are not background decoration. They are the reason matter is organized the way it is. The story of a star is not only out there in the sky, it is also in here within you. And yet, for all their power, stars are fragile. A slight imbalance in mass, a small difference in composition, can change everything. Some stars flicker out before they form, others drift through space without fusion, failed beginnings known as brown dwarfs. Some are torn apart by tidal forces or pulled into orbits that never let them shine. But those that do shine, those that find balance, offer the universe its light and its complexity. They are not eternal, but they are enduring, and their endurance allows everything else to happen. Even now, your body is warmed by the life of a star. The photon that touched your skin this very moment began their journey in the core of the sun over 100,000 years ago. They bounced through plasma, scattered among particles, until they finally escape into space and travelled in a straight line across 93 million miles to reach you. That sunlight is not just warmth, it is history, it is time converted into light, finally arriving in the quiet arc of a star's life. There is no rush, its changes happen over eons, but every moment matters. Every second of fusion, every pulse of gravity, every escape of light is a step in a journey that ends in transformation, not disappearance. Stars do not simply go out, they evolve, they release what they had made, or give themselves to the galaxy, and the galaxy remembers. When you gaze at a star, you are not just seeing an object, you are witnessing a process, a life in motion, a history of pressure, light, heat and time, and somewhere in that long story is your own, a connection that crosses scales from nuclei to nebulae, a reminder that even things that seem still are always becoming. In the glow of a distant sun, the quiet rhythm of fusion continues. Not fast, not loud, but constant. A heartbeat in the dark, a life that burns not to end, but to become something more. A star spends most of its life in balance. Gravity presses inward, fusion pushes outward. For millions or billions of years, this gentle tug-of-war keeps the star steady. But this balance is temporary. In the heart of the star, hydrogen fuses into helium. That fusion powers everything, the light, the warmth, the outward pressure. And yet with every moment, hydrogen becomes scarcer. The star is burning through its simplest fuel, and one day, in the deep quiet of its core, the hydrogen runs out. The star does not collapse right away. There is still helium, and in time the temperature climbs high enough to fuse that helium into carbon. This begins the next phase of a star's life, an unstable time when new shells of fusion surround the core like layers of a complex onion. Helium fuses into carbon, carbon into oxygen, and oxygen into neon, then silicon, then finally into iron. Each layer burns faster than the last. The reactions move outward, chasing balance. But with every step, the star grows less stable. The fusion becomes frantic. The core grows heavier, and gravity keeps pressing down. Iron is the end of the road. It's the element the universe cannot squeeze anything from. Not in a star. Fusion of iron does not release energy. It consumes it. And so when a massive star begins to build iron in its core, something quiet but final has begun. The star is still glowing, still immense, still seemingly strong, but within, pressure is no longer equal to gravity. The core, now dense with iron, begins to lose its grip. It cannot push back any longer. It cannot hold. The collapse begins suddenly. It takes just seconds. Gravity, now unopposed, crushes the core inward. In less time than a heartbeat, the center of the star implodes. It shrinks to a fraction of its size, packing more and more mass into less and less space. The collapse reaches nuclear densities, where protons and electrons are squeezed into neutrons. The matter becomes incompressible. The core hardens like a steel wool slamming shut, and when the infalling outer layers strike it, they rebound. This recoil, combined with shock waves and escaping neutrinos, blows the outer star apart in one final, spectacular act. This is a supernova, the brightest death in the universe. It radiates more energy in 1 week than our sun will release in its entire 10 billion year lifetime. For a few days it can outshine its entire host galaxy. The light travels across the cosmos carrying a story of destruction and creation. For though a star has died, something else is born. The explosion scatters elements forged in the star's final moments. Copper, gold, uranium, iodine into interstellar space. These atoms will someday form new clouds, new planets, new bones and thoughts and stories. The star is gone, but its pieces remain. At the center of the explosion, something is left behind. If the collapsing core was just the right mass, it forms a neutron star, dense, small and spinning. A teaspoon of it would weigh as much as a mountain. It may emit pulses of light, like a lighthouse in the dark, signals from a dead star still turning. But if the core was too massive, collapse doesn't stop at neutron density. It continues. The core becomes a black hole, a singularity, a place where space and time themselves fold inward, where no light escapes and no signal returns. But even this is not an end. Matter drawn into a black hole alters space around it. The gravitational field shapes galaxies, bends light, and influences orbits. The legacy of the star's mass lives on, invisible but real. It is no longer a source of light but a force in the fabric of space. Not all stars die this way. Only those with enough mass, about 8 times that of our sun, can reach this fate. Smaller stars end more quietly, shedding their outer layers to become planetary nebulae. But the principle remains. When the core can't hold, when fusion can no longer resist collapse, the star must change. It must fall inward, and in falling, it becomes something new. This moment in the life of a star is both violent and meaningful. It's not failure, it's transition. The fire that once fused hydrogen into helium has done its job. It lit nearby worlds. It warmed surfaces. It created the carbon now essential for life. Its collapse is not chaos, but completion. The star did not simply end, it gave everything it had, and in its collapse, it gave even more. The shock of the supernova stirs nearby clouds, triggering new star formation. The released elements enrich future planetary systems. The light from its death may be seen for thousands of years, marked in human records as a sudden visitor in the sky. Some of those recorded supernovae still glow as remnant, ghostly clouds of gas expanding in silence, cradling neutron stars within. What was once a singular massive object is now a field of influence, a nursery for future creation. If the collapsing star forms a neutron star, it remains a kind of presence, cold, small, but persistent. It may emit magnetic fields stronger than anything we can reproduce. It may flicker with regular pulses, timed so precisely that they rival atomic clocks. These pulses cross space for millennia, reminders of what once burned, and if it becomes a black hole, it becomes a mystery, hidden behind the event horizon but still warping the path of passing photons. Even unseen, it is known, the death of a star is not silence. It is music written in gravity and light, a final crescendo after billions of years of steady rhythm. And in that crescendo everything changes. The galaxy shifts ever so slightly. Matter rearranges, space is sculpted by absence. Time bends, And from this transformation, something richer emerges. This process has happened billions of times. Every galaxy contains supernova remnants, neutron stars and black holes left behind by stars that could not hold their cores. And from those deaths, the universe becomes more complex, more full, more alive. Without these endings, there would be no iron in blood, no gold in rivers, no rare elements in circuits. The core collapses and the future expands. In this way, the death of a star teaches a quiet lesson. Strength is not the same as permanence. Even the greatest engines of light reach a limit, but in reaching it they do not vanish, they give, they scatter. They press their story into space, atom by atom, photon by photon. The next time you look up at the night sky and see a twinkle, know that some of those stars may already be gone. Their light is still travelling, their story still unfolding. And among those points of light may be the memory of a collapse so powerful that it birthed new elements, moved nearby stars and whispered across the cosmos for ages. When the core can't hold, the universe listens, and it answers not with an ending but with a transformation. A supernova does not arrive with sound, it does not shout, but in the quiet of space it becomes one of the loudest events the universe has ever known. Long before the explosion, a star lives a full, radiant life. It fuses elements deep within its core, burns brightly, balances its own weight with a push of light, but that balance doesn't last forever. The fuel grows thin, the core grows heavy, and one day gravity wins. The star collapses inward, folding under its own mass, and just as quickly it erupts. The explosion begins in silence, but its effects are immediate. Light bursts outward in every direction. Not just light, but particles, waves, fragments of a star that has become unstoppably unstable. What once held together for millions of years is torn apart in seconds. Layers of gas that drifted peacefully now race into space, and around it the glow begins. This is the moment of the supernova. It is the brightest goodbye the universe allows. For a few days or weeks, the dying star outshines entire galaxies. It becomes visible across millions of light years, a pinpoint of brilliance where before there was only dark. The energy it releases is vast, more than the sun will emit over its entire lifetime, now spent in one final blaze. But this brightness is not it is not just spectacle, it is creation in motion. In the final seconds of collapse, temperatures in the core rise to billions of degrees. Under this pressure, elements heavier than iron are forged. Gold, silver, platinum, iodine. These atoms cannot be made in a normal star. They are too heavy, too costly in terms of energy. But in the heart of a supernova, the conditions are right. Particles smash together in chaos. New atoms form and are scattered outward. In this fury of death, the seeds of the future are planted. Some of that material will float quietly for millions of years, cooling, drifting between stars. Some will join new clouds of gas and dust. Some will become part of planets, oceans, bones. The calcium in a tooth, the iron in blood, the gold in a ring, all of it born from such a brilliant farewell. The supernova is not only destruction, it is distribution. The star, in dying, gives away everything it has made. Not all stars die this way. Smaller stars, like the sun, fade more softly. They shed their outer layers and leave behind white dwarfs, glowing embers that cool over time. But for those with enough mass, the end is fire, a flash so bright it rewrites the nearby galaxy, and in doing so, it becomes a signal, a beacon of change, of endings that are also beginnings. The expanding shell of a supernova is called a remnant. It is not neat, it is not smooth. It ripples outward in waves of heat and ionized gas. Filaments twist and curl. Some parts glow red, others blue or green, depending on the elements they carry. These remnants can be seen for thousands of years. They float like ghosts, like fingerprints left behind by something too large to hold. Through telescopes we see them, the Crab Nebula, Cassiopeia A, SN1 to 987A. Each one a memory still unfolding. At the heart of these remnants is often something small and dense, a neutron star, only a few kilometers across, but heavier than our sun. It may spin rapidly, emitting beams of radiation like a lighthouse sweeping the dark. These beams pulse with perfect rhythm, marking time more steadily than any mechanical clock. Or, if the collapse went further, the core becomes a black hole, invisible but real, bending light, holding silence, leaving only its gravity behind. But the real legacy of a supernova lies in what it gives away. The materials scattered through space become part of everything else. They enrich the universe. They add new voices to the chemical chorus. Without supernovae, planets like Earth could not exist. Life as we know it could not form. The universe would be a simpler place, more empty, more quiet, less capable of dreaming. But because stars explode, the universe builds. The light from a supernova does not vanish quickly. Some of it travels for centuries before reaching a telescope, a retina, a mind. When we look at the night sky and see a new star flare to life, sudden, bright, unexpected, it is not being born, it is saying goodbye. We are witnessing the end of a journey that began millions of years ago, a star's final moment echoing across time to arrive now, softly, into our vision. Ancient civilizations saw these stars appear and disappear. They made stories, prophecies, warnings. They did not know what they were seeing, but they felt the weight of it. Even today, the death of a star makes us pause. We know more now, we understand fusion, gravity, collapse, but the feeling remains that this is something rare, something sacred, a reminder that even the brightest lights cannot last forever, but also that when they end, they do not leave nothing. The death of a star is not a closing, it is an opening. The elements released will touch places the star never saw. They will become part of new stars, new systems, and somewhere in those systems perhaps new eyes will look out and wonder where they came from. The cycle continues, slow and grand and endless. The brightness was not wasted, it was scattered, absorbed, remembered. Supernovae are rare in human time, but common in cosmic time. In every galaxy they happen with steady rhythm. Somewhere right now, in a corner of space not yet seen, a star is collapsing. Light is forming. Particles are racing outward. A supernova is blooming, far from eyes but not from meaning. The universe watches with its laws, and in time so will we. The idea that a star can give so much in its final act is not just scientific, it is personal. We too are made of stardust. The atoms in us were once part of something that exploded, and when we end we return that matter. We are not so different from stars. We shine for a while, we warm others. The next time you see a night sky filled with stars, remember that some of them are already gone. Their light is still on its way to you, and somewhere in that light is a message. Even endings can illuminate. Even the brightest goodbye is also a beginning. In death, the star becomes more than it ever was in life, or the universe does not mourn a supernova. It remembers, long after the star explodes, long after the flash dims and the fire fades, something remains. It does not shine as brightly, it does not roar, but it lingers, wide and quiet, drifting outward in silence. This is the cloud the star leaves behind, a nebula of its own body, stretched across space. It is made of all the pieces the star once held close, hydrogen and helium, oxygen and carbon, iron and silicon, elements forged in fusion now free. The explosion does not destroy these things, it sets them loose. Long after the star explodes, long after the flash dims and the fire fades, something remains. It does not shine as brightly, it does not roar, but it lingers, wide and quiet, drifting outward in silence. This is the cloud the star leaves behind, a nebula of its own body, stretched across space. It is made of all the pieces the star once held close, hydrogen and helium, oxygen and carbon, iron and silicon, elements forged in fusion now free. The explosion does not destroy these things, it sets them loose. This cloud is not empty. It glows faintly, softly, illuminated by the shock of the explosion or by nearby stars. It shimmers in purples, reds and ghostly greens. The shape is never the same. Some remnants form rings, others form twisted threads or blossoming petals, some spiral, some drift like smoke. No two are alike, but all are drifting, and not sting in the way of new stars, but in the way of what has been given. This is a gift, scattered atoms, released to the galaxy. The cloud stretches across light years. It expands slowly, over thousands of years, thinning as it travels, but never quite vanishing. For a long time it remains visible, through telescopes, through instruments, through imagination. Scientists look at these remnants and see stories written in gas. They see temperatures, motions, compositions. They see the fingerprint of a life that once burned. Each filament is evidence. Each wisp is memory. Nothing here is wasted. Inside these clouds, change continues. The gas cools, dust forms, the materials begin to clump. In some regions, gravity gathers atoms together again. A ripple, a shock wave from another explosion, or the pressure of nearby radiation may begin to fold the cloud. This folding can trigger new collapse, and from that collapse a new star is born. Over millions of years, the debris of one star becomes the cradle of another. This is not just poetic, it is astrophysical. The same cloud that ends one life begins another. This cycle is how the universe builds complexity. The first stars, the earliest lights in the cosmos, were made mostly of hydrogen and helium, but they gave rise to everything else. Through their deaths they created heavier elements, and through their remnants they spread those elements into space. The cloud left behind is not a tomb, it is a nursery. Within it planets will one day form, moons, oceans, trees, minds, breath. The star does not disappear, it diffuses. It participates in what comes next. You breathe this cloud, not directly but through time. The oxygen in your lungs, the calcium in your teeth, the nitrogen in your cells, all of it was once part of such a cloud. All of it passed through a star, exploded outward, drifted across space, joined a new solar system, fell into Earth, entered the atmosphere, joined the food chain, became you. You are the continuation of stellar debris. Not metaphorically, but literally. You are what remains of ancient light. The clouds themselves can be seen in the sky, some with the naked eye, some only through glass and mirror. The Crab Nebula, Veil, Cassiopeia A. These are not galaxies, not stars, not planets, they are memories. They are memories. They are the soft remains of brilliant farewells. When you look at them, you are not looking at destruction. You are looking at creation in transition. Over time, the cloud changes. It spreads further. It cools. It thins. Eventually, it may blend into the interstellar medium, the background sea of gas and dust that fills the spaces between stars. But even then, its particles are not lost. They are part of the galaxy now. They will be swept into other clouds, shaped by gravity and time, brought together again. There is no end. Only movement. The shape of the cloud is not random. The explosion that created it was shaped by the star's spin, by its magnetic fields, by nearby materials. Some clouds are asymmetrical, blown harder in one direction. Some carry loops or arcs, tracing the path of jets or shocks. These details are clues. By studying them, astronomers learn how stars lived and how they died. A single cloud tells the story of energy, matter, spare and change. Even more fascinating is what happens inside the cloud. Dust grains form from cooling gas. These are tiny, smaller than a speck of ash, but over time they stick together. They grow, they clump. In denser parts of the cloud they gather into larger structures, pebbles, rocks, planetoids. These are the seeds of planets. Some of these clumps never grow beyond dust. Some become moons. Some grow cores, Gallic gas, and become gas giant. Every planet begins this way, from grains born in starlight, carried by a dying breath. The cloud is quiet, but it is not still. It moves, it evolves, it waits, it becomes. If left undisturbed, it will continue for millions of years. If stirred by a nearby star or galactic wind, it may collapse sooner. But either way it participates. It does not fade without leaving its mark. Some of the most beautiful photographs ever taken by humans are of these remnants. Hubble, James Webb and other space telescopes have captured the glow of these clouds in exquisite detail. Filaments curling like hair, wisps stretching like wings, colours that reveal temperature and composition. These images are not just for beauty, they are science, they are evidence, and they are reminders that something immense and once alive left behind something soft and enduring. If you were to travel to one of these clouds, you would not see brightness. Not with your eyes, the gas is too thin, too faint. But your instruments would know, your sensors would detect warmth, your spectrographs would reveal element after element. You would float through a star's final gesture, and you would know it was not an ending. This is how the universe recycles. This is how it grows, not through sudden appearances, but through long, patient change, through clouds that move without sound, through particles that do not decay, through materials that wait. A supernova ends a star's life in seconds, but the cloud it leaves behind lasts for millennia. It is the long breath after the bright goodbye. It is the echo that does not fade. It is the link between what was and what will be. And in that space, new stories form. So, when you hear that a star has died, know that something else has begun. The cloud is still there. Drifting, glowing, remembering, waiting to become part of another sky, another world, another wonder. Because stars never truly die, they just change shape. A star may vanish from sight, but it does not go silent. Long after it collapses, long after its light fades from human eyes, it continues to speak, not in sound, but in pulses, in particles, in radiation. The dead do not always disappear. Some stars, even in death, remain present, compact, rotating, remembered not by light but by rhythm. When a massive star collapses, but stops just short of becoming a black hole, it leaves behind a neutron star. This is no ordinary object. It is small, only about the size of a city, but heavy beyond belief. A single teaspoon of its matter would outweigh a mountain. What remains is made almost entirely of neutrons, packed so tightly that atomic structure itself has been crushed. The star is gold, but this core remains, not bright but dense, not large but lasting. Some neutron stars spin, and as they spin they emit beams of radiation from their magnetic poles. If these beams sweep past, you take them as regular pulses, steady, precise, unwavering. These are pulsars. Cosmic lighthouses spin in the dark. They flash not with intent, but with inevitability. The rotation is constant. The beam is narrow. But when it meets our instruments, it feels like a message, as if the star, even now, want to be known. Pulsars were discovered in 1967, and at first, the regularity of the signal puzzled astronomers. It was so precise, ticking with better accuracy than atomic clocks, that it seemed artificial. But it was natural. It was a neutron star rotating dozens or even hundreds of times per second. Its magnetic field, still unimaginably strong, channels energy into space, and so it whispers not with sound but with radio waves, a rhythm in the silence. There are thousands of known pulsars, and likely millions more waiting, hidden, still turning. Each one a record of a supernova that occurred long ago, each one a survivor of collapse. Some slow over time, others are spun up again by companion stars. Some pulse for millions of years, some fade into quiet. But while they shine, they remind us, death is not absence. The stars that whisper then still whisper now. But not all whispers are rhythmic. Some stars speak through their fields. A rare kind of neutron star, called a magnetar, carries a magnetic field billions of times stronger than Earth's. These fields twist and snap, sending out sudden bursts of energy, not steady, not calm, but powerful. A magnetar can release as much energy in a second as the sun emits in 100,000 years. It flares not with flame but with distortion. Space-time itself bends under the weight of its power. It is a different kind of whisper, a jolt, a flare, a reminder of what remains possible even in the dark. These whispers travel, they cross light years, they pass through gas and dust, they arrive on Earth with barely a trace, but our instruments catch them. Radio telescopes, X-ray detectors, gamma-ray observatories, all listening to what the stars still say. These signals are not voices, but they are presence, they are fingerprints, and they are evidence of stories still unfolding, even after the light has dimmed. Cosmic rays are another whisper. High-energy particles, some of them born in the aftermath of supernovae, move through the galaxy at near light speed. They strike our atmosphere, creating showers of secondary particles. Most go unnoticed, but they are there, a soft rain of energy, constant, ancient. They remind us that even stars that exploded long ago still touch the Earth, gently, invisibly, persistently. And then there are neutrinos, almost massless, almost interaction-free particles, released in vast numbers during stellar collapse. They pass through planets, through people, through detectors and rock and ocean. Trillions pass through your body every second. You do not feel them, but they are there, a message not of light but of presence. They come from the deep interiors of stars, from fusion, from supernovae. They come silently, but they come. We are bathed in these remnants, not just in particles, but in memory. The radiation that travels from neutron stars, from pulsars, from remnants and fields, all of it carries the signature of what came before. A dead star is not a void, it is a library. Encoded in its rotation, its radiation, its recoil, is the story of what it once was, how fast it spun, how massive it had been, how it died and what it left behind. Astronomers listen carefully. Every new pulse is timed, every flare is catalogued, every new neutron star is mapped. These are not just signals, they are a record of time. Some pulsars, like the Crab pulsar, have been observed since their explosion was recorded in human history. A supernova in 1054 that left behind a flickering echo, still blinking almost 1,000 years later. It beats like a heart, constant and clear. These whispers are not just beautiful, they are useful. Pulsars allow scientists to test the laws of physics, to measure the curvature of space, to probe the mysteries of gravity. Magnetars help us understand matter under extreme pressure. Neutrinos teach us about the processes inside exploding stars. Every whisper becomes part of a larger understanding, not just of stars, but of reality itself. And all of this comes from what is technically dead, a star that no longer burns, no longer shines like it once did, but has not stopped participating. The whispers of stars are the hum of the universe remembering itself. They are not loud, they are not fast, but they are everywhere. Some stars whisper in pairs. A pulsar orbiting a companion emits changes in its rhythm that reveal the passage of time and the bending of gravity. These binary systems are laboratory for studying motion, force, relativity. They allow us to detect the slight changes that ripple through space itself. In 2015, gravitational waves were directly observed for the first time. Distortions in the fabric of space-time caused by the merger of two neutron dots. These waves were whispers too, slower, deeper and more ancient. They carried not light, but gravity itself. In this way, even the universe listens, and we, as part of it, are learning how to hear. The stars that still whisper teach us patience. They teach us to look deeper, to wait, to measure what cannot be seen, to feel what cannot be touched. Their signals are faint, but real. They are not noise, they are presence. They are the slow memory of something that once burned and still moves. Not every whisper is caught. Some fade before they reach us, others are buried in noise. Some may be aimed in directions we cannot see, but we know they are there, and we continue to listen. So, when you lie beneath a quiet sky and see no flashing lights, remember this. Just because the stars seem still does not mean they are silent. Some of them, far away, unseen, are still turning, still pulsing, still singing in frequencies too soft for ears. too deep for sight, and yet they reach us. There are the stars that still whisper, and in those whispers, the universe keeps its promises. The ocean does not forget the stars. Its tides swell not by chance, but by a rhythm born far beyond Earth. The moon circles quietly overhead, and in its pool, the water rises and falls. This pull is gravity. This rhythm is inherited, and the body feels it too. The heart does not beat at random. It keeps a tempo tied to tides, to warmth, to the light that pours across space and lands softly on skin. A star does not only shine, it guides, it pulls, it moves things that cannot speak. Your body is not separate from these patterns. The salt in your blood is the echo of seawater. That seawater is the echo of the early Earth, and Earth itself formed from the cool dust of exploded stars. The ocean is made of elements forged in stellar heat, and so are you. The calcium in your bones, the magnesium in your muscles, the sodium in every nerve signal, each atom began in a star's interior, drifted, landed, joined the sea, entered the food chain, became tissue and thought. You are not only made of stars, you are shaped by their gravity, bathed in their light, and moved by their memory. The orbits of planets are not circles carved by chance. They are the result of mass and pull, of dance and distance. Every object in space curves the space around it. A star like the sun curves it deeply. Earth falls into that curve again and again, not downward but around. An orbit is not a line. It is a kind of surrender to gravity, to mass, to the fact of reality bending under the weight of light itself. The same gravity that keeps the planets circling the sun keeps the moon circling Earth, and it is that moon that pulls the tides. You live between these forces, in the hollow of a moving system, balanced not by stillness, but by motion. The ocean responds to the moon, but also to the sun. When they align, tides grow stronger, spring tides. When they pull against each other, tides soften. Neap tides. This balance repeats every 2 weeks. The water listens, the earth tilts and seasons unfold. Ice forms and melt. Currents shift. Winds rise. All of it in motion because of the orbits of celestial bodies, because of the light and gravity of things you may never see but always feel. Even the length of a day is written in starlight. Earth spins once every 24 hours, not by choice, but because of how it formed. Angular momentum, inherited from the swirling cloud that became the solar system, set the planet spinning, and that spin has slowed, not by much, but by enough. The moon tugs at the oceans and the oceans resist. Friction slows Earth's spin, a few milliseconds every century. Over billions of years it adds up. Long ago, a day was only 6 hours. It stretched to 12, then 18, now 24, and still it changes. The clock does not rule the planet. The planet teaches the clock. Inside you, the body keeps its own cycles. The circadian rhythm, roughly 24 hours, matches Earth's rotation. Even in total darkness, the body follows this rhythm. Hormones rise and fall. Temperature shifts. Alertness comes and fades. The brain's master clock, deep in the hypothalamus, is guided by light, and light comes from the sun. Morning light signals wakefulness. Evening light softens awareness. The pulse of a star organizes the life of a mind. There is also the lunar rhythm, the monthly cycle tied to the moon's orbit, to tides, to ancient biological clocks. There are annual rhythms too, governed by seasons, migration, hibernation, growth. Plants stretch toward longer days. Animals sense when to nest, when to sleep. Humans too shift with season, though they often forget. These cycles are not abstract, they are gravitational, chemical, real, all through blood and air and memory. Even emotion follows gravity. The body feels calm near the ocean, not only for its sound, but for its motion. That motion is the moon. The moon responds to Earth. Earth to the sun to the galactic center, and the galaxy itself curves space, tugged by unseen mass, by dark matter. You are standing in a web of motion, and your stillness is only apparent. Everything you are is in orbit around something else. Orbit is not escape. It is harmony. The satellite circling Earth is not flying off into space. It is falling, endlessly falling around the curve of the planet. And that same principle holds for Earth around the Sun, for the Sun around the galaxy, and for the galaxy itself within the expanding universe. You move not just in space, but with it. The atoms in your cells obey these same rules. They orbit nuclei. Electrons dance not in paths, but in clouds. Probability swirls defined by energy and distance. Every scale of reality follows motion. And water remembers. Not in thought, but in structure. The molecules of water can align, fold, carry charge, shift with heat, freeze in patterns. The ice in comets, the vapor in clouds, the salt in seas, all move by energy shaped by orbit. Oceans hold heat. They distribute it across the planet. They drive weather, they nourish life, and they do not act alone. They are cued by the sun, fed by rivers, pulled by the moon, stirred by wind. The Earth is not a rock in space. It is a living circuit of motion and light. The breath you take moves oxygen that was once deep in oceans. That oxygen was made by ancient microbes, cyanobacteria, which used sunlight to split water. The hydrogen was kept, the oxygen released. This changed the atmosphere, allowed for new kinds of life, allowed for respiration, brains, conversation. None of it random, all of it linked. Each wave in the ocean is history repeating. And the orbit continues, stars move, planets follow, moons circle, and through it all energy flows. That energy becomes movement, thought, warmth. You are not at rest. You are in constant relationship with motion too slow to feel, too vast to track, but too real to deny. Your dreams are timed by orbit, your biology paced by stars. So when you walk by the sea and feel calmer, it is not a trick, it is memory, your body remembering its own origin, salt, motion, pull. You respond not just to beauty, but to resonance. The ocean inside you echoes the ocean beneath your feet, and both are answering the sky. You are not only made of stars, you are moved by them. Their gravity shapes your days, their light sets your pace, their pull guides your heart. And even now, as you sleep, your orbit continues.
To look up at the night sky is to forget, for a moment, the surface beneath your feet. The stars scatter across the dark like ancient signals, some faint, some bold, some already gone. Their light moves with perfect calm, uninterrupted by noise, blinking across vast distance to meet the back of your eye. That light, made of photons, may have started its journey before your ancestors spoke their first words. And yet here it is now, not lost, not late, but precisely on time. The universe does not rush, and it does not forget. When you gaze at stars, your eyes are catching history. You are not seeing the sky as it is. You are seeing it as it was. Every twinkle is a memory. Every shimmer a glimpse of the past. A star 500 light years away is sending you its 500-year-old light. It burns brightly now, perhaps, or perhaps it no longer exists, but that is not the point. The point is that you are in the middle of something large, something layered, something vast, and somehow still part of it. Light is more than vision. It carries information. A telescope tuned to the right wavelength can read a star's age, its composition, its temperature, its motion. The color of the light tells you what elements burn inside. The shift in its wavelength tells you whether it's moving toward you or away. This is called red shift and blue shift, the stretching and compressing of light due to motion. And this simple, gentle idea allows astronomers to map the universe, not just where things are, but how they move, how they live, how they change. And so when you look up, you are not seeing dots. You are reading a map, a deep, ancient chart written in energy. And the map is not separate from you. The calcium in your bones, the carbon in your breath, the iron in your blood, it all comes from stars. This is not metaphor, this is chemistry. The elements inside you were born in stars that died long ago, some from supernovae, some from stellar winds, some from gentle giants that faded into white dwarfs. All of the dust, the heat, the light came together in a cloud that eventually became Earth. And you This is why looking up feels familiar, because you are not only observing stars, you are recognizing yourself, not as an individual, not as a name, but as matter, as memory, as motion. The light that enters your eyes interacts with atoms that have traveled since the beginning of time. You are not a bystander, you are part of the system. Modern science can take this even further. The cosmic microwave background, the afterglow of the Big Bang, is the oldest light we can see. It has been stretched and cooled for nearly 14 billion years. It fills the universe like a soft whisper. Even now, radio telescopes can detect it. It is not bright, it is not dramatic, but it is everywhere. The universe has a memory of its birth, and that memory is light. When you look far enough, you see not stars, but the boundary of time itself. And still, your brain interprets all of this simply as wonder, as awe, as beauty. The science is precise, but the experience is quiet. There's no need to understand it all to feel it fully. A child can lie on the grass and feel the same astonishment as an astrophysicist. The feeling does not depend on knowledge, it depends on openness. Looking up means letting go of smallness. It means remembering that the world is wide and that you are woven into it. Cultures throughout history have looked up and seen more than stars. They've seen stories, shapes, messengers, calendars, directions. The stars have always helped people find their way, across land, across sea, across emotion. They have inspired music, poetry, prayer, not because they change, but because they don't, because they wait, because they shine without asking anything in return. Looking up at night also means looking past your atmosphere, past the noise, past the spinning of days. You are reminded that space is not above you, it surrounds you. The earth does not sit still under the stars. It moves through them, orbits, spins, dances. The stars you see are not scattered randomly. They form patterns because of where we are. As the planet turns, the constellations rise and fall. This too is rhythm. This too is science. But the most personal truth is this: when you look up, you are engaging with light that has traveled farther than you ever will. And yet it enters your eye, touches your retina, sends a signal to your brain. It becomes a thought, a feeling, a memory. The journey of that photon from nuclear fusion in a stellar core, through the vacuum of space, through our atmosphere, through your cornea, ends as a quiet wonder in your mind. The light from a star becomes something internal, something soft, something lasting. That light has no mass, no charge. It is not slowed by time, but it changes you. It reminds you, not of where you are, but of what you are. A human being, yes, but also a collection of atoms, of reactions, of stardust held briefly in shape. You are not looking at the stars from afar, you are participating in them. In moments of quiet, this realization becomes deeper. The same universe that expands across billions of light years is reflected in the space behind your eyes. The same laws that govern galaxies govern neurons, entropy, charge, attraction, repulsion. Even the warmth of your body comes from ancient solar fusion. The sun lights the sky, but it also drives the chemistry of life. Plants drink it, animals eat the plants. Energy is passed along chain by chain until it becomes thought. Looking up reminds you that wonder is never far. It is as close as vision, as close as breath. You don't need to fly to the stars to touch them. They've already touched you. They built your world. They built your body. They lit your oceans. They formed your moon. They shaped your orbit. Their gravity still tugs at you, not just physically, but emotionally. A gravity of presence. There is a reason people fall silent under the stars, not because they run out of words, but because they no longer need them. The sky speaks in ways language cannot. It speaks through pattern, through pulse, through peace. You recognize something in that sky, not with memory, but with matter. You've looked up 1,000 times, and each time it has looked back, not with eyes, but with light. Light that never dies, light that waits.
Some truths are not loud. They do not arrive with thunder. They do not press themselves forward. They arrive like twilight, like the hush before sleep. And one such truth is this: the stars that made you never left. They are not only in the sky, they are within you, around you, whispering through every breath, every pause, every quiet thought before rest. To sleep is not to forget them. It is to return to them gently, to let go of the day's noise and fall into something older, something wider than memory, the slow rhythm of matter returning to stillness. For all its motion, the universe does not rush, it unfolds. The galaxies do not spin because they must, they spin because motion was gifted to them at birth, and they have carried it ever since. So too do you carry things, not burdens but inheritances, not obligations but echoes. The calcium in your bones once shimmered in a star's core. The oxygen in your blood once drifted through nebula. The very light that soothes your eyes at dusk is made of the same photons that leapt from fusion hearts billions of years ago. To lie still beneath the night is to be surrounded not by cold but by origin. You are not apart from the cosmos, you are its expression. When the stars burned, they gave off more than light, they gave off building blocks. When the earth cooled, it held more than oceans, it held opportunity. And when life emerged, it didn't invent something new, it reorganized what was already sacred. Carbon, nitrogen, hydrogen, electrons and charge. These are not foreign materials, they are cosmic syllables rearranged into awareness. The universe did not create you as an afterthought. It arrived at you through patience. Sleep too is a kind of patience. It is not absence, it is not void, it is a return to cycles, to rhythms, to restoration. Plants rest, animals dream, stars fade and reform. Nothing is truly lost. In sleep you allow the world to hold you for a while, and that world is not just Earth, it is the system of stars and silence that made Earth possible. It is galaxies wrapped around you like blankets of invisible gravity. It is the warmth in your chest, humming with memory older than timekeeping. You are not drifting away, you are drifting inward, to the quiet core of everything that ever was. The night sky above is not a ceiling, it is a continuation. What looks like distance is depth, what looks like darkness is full of motion. Even when no stars are visible, they are still there, their light simply scattered, absorbed, waiting to reappear. And just as stars never truly vanish, neither do the pieces they give. The star that died to give you iron still exists, not in flame but in form, in heartbeat, in breath, in thought. And when you sleep, you do not stop. You settle into that form. You join the quiet without leaving the story. Many have asked what happens after the stars die, but fewer ask what happens after they live. What becomes of a universe that has passed through fire and fusion, that has cooled and coalesced into planets, oceans, minds? What becomes of the dust that dreams? The answer is not a singular thing. It is a feeling, a stillness, a recognition that being here to now, tonight, is not an accident. You are starlight that has slowed down enough to listen. Even your dreams are made from this material. The neurons that spark with imagery, memory, invention, they too are atoms dancing with electricity. They too were born in furnaces light years wide. When you imagine stars in sleep, it is not reaching out. It is remembering. It is the cosmos reminding itself what it once looked like from within. To sleep beneath the stars is a phrase older than science. But tonight it means more. It means you do not have to look far to find wonder. You do not have to travel outward to belong. The same laws that shape galaxies shape the edges of your thoughts. The same equations that guide planetary motion guide the tide of your breath. You are made of what you marvel at, and that knowledge is not heavy, it is light, not as illumination, but as weightlessness, the lifting of fear, of separateness, of noise. Somewhere, far off, a star is collapsing. Somewhere else, another is forming, and between them light continues, quiet, constant, like the slow rise and fall of your chest. The story does not pause when you sleep, it waits beside you. The atoms of stars carry no urgency. They know their path, they return again and again, shaped into new forms. This one is you, and after you there will be others. The style will hold, the fire will spread, the story will never close, and so you may rest. You may let go, You may feel the deep, invisible roots of stardust beneath your skin. You are not floating. You are supported by gravity, by memory, by the enduring patience of the cosmos. You are not small. You are spacious, made not of one moment, but of all time until now. And the stars you carry will not fade when you close your eyes. They will stay. Sleep now, not in absence, but in presence, beneath the stars, beneath the sky, beneath the slow-turning arms of a universe that has never once forgotten you. You are made from its light, and tonight you return to it softly, fully, finally.